Hi everybody, this is the video introduction to R. I'd like to start off this introduction with a little caveat that R is not my, my main software package. I will typically do all of my data cleaning, anything I need to do to set up the data, any type of recoding in another software, usually Stata or SPSS. And then I'll usually just take my file, bring it into R, do what I need, and take it out. So with that said, I will give you, this is my, my basic introduction into R. On Canvas, I've linked some instructions for installing R and RStudio. RStudio is, this is RStudio here. It's basically an interface that interfaces with R. If you just download R, you're basically just looking at just this one little console. So RStudio makes it a little bit easier to use, and there's some instructions on Canvas here for installing R and RStudio. You can also just Google it. It's really easy. First, you need to install R from the R project, and then go and install RStudio. Let's see. I have R version 3.5.1. It's a little old now. But I think they're up to 3.6. So you can install the newest version if you want. And you can have multiple versions of R installed. Let's see, how many versions of R do I have installed? I have R 3.1, 3.5, and 3.3 installed on my computer. So I mean, you can have multiple versions installed. Okay, so once you get R installed in RStudio and you open up RStudio, you'll have a blank environment like this. So the window's divided into 4 panes. This upper left-hand pane is the source pane, and this is where it's basically your syntax or your script editor. This is where you'll type in your syntax and be able to save it as a file that you can then come back to later. Below this is the console. You can type commands into the console here, like we want to see what is 2 plus 2. It's 4. But it doesn't save anything, so it's usually better to type it into the source pane up here, so then you can then save the syntax that you want. Any variables create, data sets will all be saved over here in your environment. Different objects that you have. This bottom pane here will list all the packages you have installed. If you want to, instead of typing in library and installing a package, you can just check this box and it'll install the package for you. You also have access to your files. If you create any plots in R, they'll pop up over here in this window. It also has a help window here that you can view. So I mean, we could click on one of these as the boot function, and then you can get the help menu for that package as well. So I'm going to open the script file that I've written for this little intro video, and we're going to walk through it to kind of give you an introduction into R. And this file will be saved on Canvas, so you can kind of play with it and use it later. So you mean you can use R like a calculator? I just did that earlier. You know, you say highlight 2 plus 2, run it, and it'll tell you right here the answer is 4. You can assign objects value. So here we're assigning x. We'll make x an object and assigning a value of 3. Assign y a value of 4, and let's multiply them together. We get 12. We can also make vectors using this C. So this is like combine. So we want to make an object W, and then it's going to list just objects 1, 2, 3, and 4. See, so, and you see how they're all showing up in our environments here. So we have Y, how it's defined. W is then defined as a numerical vector. 1 row, 4 columns, like that. We can. Now we're going to multiply then 3 by our vector here. So notice that from W, multiplied it by X, so everything in there got multiplied by 3. We can also create string characters. So here I'm going to create a string character called gender. And you can see, so this is now then a string vector, right? It's a vector of just string characters where I have 1 male, 2 male, 3 males, and 2 females in it. Sometimes in measurement and psychometrics, we need these vectors to be factors, so we can use them in analysis, and so we can convert that. So let's convert the gender here to, now instead of it being a vector, a character vector, it is now a factor with 2 levels, male and female. And you can see how we assigned. Males were assigned 2s, females were assigned 1s here. So objects that perform different operations in R, these are known as functions. And usually a function starts off with the function name, and then you give it your arguments. Now you can write your own functions in R, but we'll typically be using a package that contains a set of functions. And so we'll talk about that in a minute. R will typically save in what it usually works out of what they call a working directory. This is where your files are stored. Anything you want saved, so you can see, well, what working directory am I working in? I'm working on the H drive, my documents. I want to change that to my class folder. So I'm going to set in the working directory here. And if we get the working directory again, we can see here that it's set to the to my psychometrics class folder. Notice in R, typically like in Windows, if you open, you have a directory, and you copy the file address, notice the backslash, the slashes are different. Windows uses, what is this, a backslash, and this uses a forward slash, or I may have mixed those up. But so basically the idea is you can't just copy and paste the file directly from Windows. You'll need to change all of those items. So just be aware of that when you're, so that's why sometimes it's easier to go ahead and set the working directory. Then we don't have to give the file path name every time that we're trying to use it. So we're going to open up our messy data set and, just do a little work in it. So we can either call the library foreign, which opens up foreign data sets that aren't native to R. And so we can either do it by using the library foreign package, or we could come over here and try to find foreign in our packages and just click the click box and it'll open it up. If we've never opened or installed this package before, you can use this install packages command, and you'd say install packages, parentheses, quotes, foreign. And you only have to do that one time. You only have to install the package one time, and then you call it using the library. So we are going to open the package foreign, and we're going to use the function in the foreign package called read DTA, which means read a data set. From experience, I've seen that the foreign package reads data sets better than it does SPSS ones, so that's why I'm recommending using it. So we can highlight that, run it, and there it is. So now we see it popped up in our environment here. You can use your whatever, click this little icon here, and you can see, you have your variable name. Asked quest is a factor with 4 levels, never, sometimes, and then you can see some of the values that are stored. Missing values, it uses the NA to represent a missing value. So you can look through here and see what's in your data set. You can also, if you click on here, your part of your data set will populate in the console here. So we've opened our data set. One of the packages we're going to be using in this class is the psych package. It has some nice factor analysis, item response theory, different functions. So we can go ahead and if you haven't already, you can install the package. And to do that, you could just remove this little hashtag or £. If you haven't noticed already, the £sign is the comment indicator for R. So you can put it anywhere, and then anything after that, it is going to ignore. So let's see. Let's open the psych library. There we go. If we want to get some information on the psych package, we could type a couple question marks. Hit psych, and then in our viewer here should show up some information on the psych package. Give it a few, there it goes. So then you can find, you can get an introduction to the psych package. And, it'll pop up in your PDF viewer. You could also, click the button and you can get, a list of all the functions. So, we're going to estimate, we want to find, Chromevox alpha, and we can get then the function for alpha and what's involved in that function. So, to be able to run a Chromevox alpha, let's do the same thing with those collaborative learning items we did in the STATA video. The first thing we need to do is, it wants, you see here, alpha, it says X. X here is a data frame or matrix of data, or a covariance or correlation matrix. Well, we don't want to get an alpha for the entire NESI data set. So we're just going to save out a new data frame with just the collaborative learning items. So that's what I did here. We're going to make a new object called CL, and it's going to be a data frame. We're going to take my data and then the CL ask help column, my data, and the CL explain, and so on. And then my data CL study, my data CL project. So let's get that data frame here. So we can see we have 29,365 observations from 4 variables. And we can see my data.askHelp is a factor with 4 levels. CL explains a factor with 4 levels. Now, the psych package doesn't want these to be factor variables. It wants them to be numeric. So we're going to change them, all of these. Instead of them being factors, we're going to make them all numeric. So let's run. So basically it was take the collaborative learning, take the CL data set, take this column, and then make it as numeric. Then all we have to do is just do our alpha function with our data frame. And here's our results. We can see the raw Chronobox alpha is 0.81. The standardized version is also 0.81. We also get a 95% confidence interval. 95% so lower 0.81, alpha 0.81, and the upper is 0.82. So pretty tight confidence interval. You get item statistics here, non-missing response frequency for each item. And so, we can look back in the details here to interpret some of these other pieces. Another package we're going to use in this class is the Laban package. It's a structural equation modeling package that can also be used for confirmatory factor analysis. You can also think of a structural equation model as, or you can think of a linear regression model rather as a special case of a structural equation model. So, let's do that. So we can open the Laban package, and then we need to define our regression model. So we create an object where we define our model. I'm just going to say, GPA. We're going to regress GPA on the time students spend preparing for class, how often they ask questions in class, and whether or not they were in a STEM major or not. The type of model I'm fitting, I want to fit a model using full information maximum likelihood, which Laban doesn't like you to have categorical data while doing that. So I'm just telling it to make these two items numeric rather than factors. We can run that, define our model. We're going to fit the model, ask for summary statistics from the model, and ask for the R squared from our model. So we can see iterations ended normally. Here are the number of observations used. There were 2 patterns of missing data. And then we have our estimates. Here's the intercept. Here is our unstandardized coefficient for time spent preparing for class, standard error, and a z-value. So basically does a walk test for the estimate divided by the standard error here, and then our p-values. So, for every 1 unit increase or for every 1 hour increase in the time spent preparing for class, on average, the GPA increases by 0.036 units. Same things, those who are non-STEM majors tended to have lower GPAs than STEM majors. Those who asked questions in class had higher GPAs than those who don't. Someone who had, you'd interpret the intercept, someone who was not a STEM major, never asked questions in class, and didn't spend any time preparing for class. This is their estimated GPA. And then you can see our model isn't very good. It only explains 5% of the variance in GPA. But I just thought it was just a quick example of the actual Laban package that we're going to be using. So that was my just very quick overview of R. There's lots and lots of resources for R online. I tried to find, I mean, this is just a few different resources of using R. I'm going to try to provide you all the syntax you need to be able to run the things that we're going to be doing in R, but it's basically one of those things where it just takes a lot of practice to be able to use it. Don't forget, if you to save your script file here, save it as a new file. And if you have any questions, as always, shoot me an email, stop by my office, and I look forward to seeing you in class. Thank you.